All right, tonight we are going to discuss the central limit theorem, which I'm going to say we're going to do something very similar, almost identical to what we did last class in chapter 6.3. Okay, if you remember, that was finding probability using your z-scores and mainly your calculator. So we are going to be using this calculator again, going back to this distribution and normal CDF. We're going to stick to just normal CDF today. We're not going to do anything else other than normal CDF. Okay? Just for 7.2. Now, here's the big difference of what we're going to do today. And I'm going to write this down up here, kind of really go through this. All right. So last class, we had questions that gave us mu. Let's say we're doing the IQ test again. All right. Span IQ test, the average score is 100 with a standard deviation of 15. And the question is, what is the probability that someone will score above, let's say, 125. All right, so what's the probability that someone will score above 125? Okay, so this is a greater than question. If you remember, greater than, we change the lower bound. So we have lower bound, and we have upper bound, which are generally at a standard -1 E99. What this means is that is negative infinity, all right, and +1 E99, that is positive infinity. So basically, that E99, what it stands for, if you remember scientific notation, our calculators don't do scientific notation, instead they just do E. So what that represents is -1 times 10 to the 99th power. So basically, negative infinity. All right, and this stands for +1 times 10 to the 99th power, which your calculator actually won't do. If you do put in your calculator, it will give you scientific notation. It'll basically just spit that back out. So, that's what those stand for, by the way, in case you were curious. All right. So since this is greater than, we're going to change our lower bound. So our lower bound is going to change to 125. We're going to put in the mu, we're going to put in the sigma, and then we're going to find the probability. And that was it. So let me do that. And we'll go down to normal CDF. So normal CDF, say 100 was the mean. 15 was the standard deviation. Change the lower bound to 125. 125. And then we calculate. So probably something scoring above 125 is about 5%. Okay, we usually put 0.0478 because you got to round that part right there. All right. So that's what we did last class. We did a lot of that. We did less than, we did greater than, and we did between. All right. Now here's the difference of what we're going to do today. All right, and this is what the central limit theorem says. We're going to change this question just a little bit. It's going to say, what's the probability that let's say something like given a sample of 10 tests, what is the probability Well, let me get rid of that. Sorry. Kind of started this out bad. All right. I'm gonna run out of room anyway, so here's the difference. We had, what's the probability that someone scores above a 125? What's the probability that, let's say, 10 people score an average above 125? Okay, so that's the difference. All right, if you kind of, I don't know if you've noticed the difference or what's the major change here, but they're introducing a new variable. Okay, and that new variable is sample size. Now, if you remember the symbol for sample size, it is n. All right, so n is equal to 10. So if we have a sample size, what's going to change is how we calculate our z-score and how we use our calculator. Now, in chapter 6, that's terrible. In chapter 6, we had basically a sample size of 1. N equals 1 for every question. All right, so we had z is equal to, what was it? X minus mu over sigma. But in chapter 7, when n is not equal to 1, basically we'll say n is bigger than 1, because you can't have a negative sample size. Our new formula is this: z is equal to x bar minus mu over sigma divided by the square root of n. That is our new formula for z. Now, here's the nice thing. You don't have to know the formula right now. You're going to need that formula for chapter 10, but you're not going to need it for today's assignment because there are no questions that just ask for z-scores. Don't ask me why. I didn't make the questions. I just can only give you the ones I'm offered. Okay. So, but here's what you're going to do instead. Okay, let me clear this. So I just kind of want you to get an idea of what, oh, sorry. I don't know what that is. Chapter 7, all right. Here's what you're going to do. Now you're going to do something very similar to what we just did, all right? But you're going to change one thing and only one thing, all right? And what I mean by that is you're going to change one thing you do on your calculator, all right? So this is what you're going to input in your calculator. Given that same question, all right, that we had, mu was 100, all right, sigma was 15, we had a sample size of 10, and we want to know what was the, that the scored an average of 125. Now, I don't know if you picked up, but the symbol changed a little bit here. Okay, remember we had x minus mu over sigma versus x bar minus mu over sigma divided by square root of n. This right here is a random value. All right, this right here is the sample mean. All right, now mu, if you remember, is the population mean, but there's also another word for it, which is expected value or expected value. Now, the reason we had just one random variable, because we only had one random person, was probably that one person scored above 125, about 5%. Was probably 10 people doing that? Well, we can't plug in 10 different things, so what we did is we averaged those scores and say they had an average of 125. So that's where this comes. Because we have a sample size, we have to average those scores to get just one number. All right. So what you're going to put in your calculator is this. You're going to have mu equals, or I think it was a mean equals mu. All right, equals 100. Sigma equals 15, but this is the extra part you're going to add in. Divided by the square root of 10. All right. And then you're going to change your lower bound again. Lower bound, that's going to change to 125. And upper bound we leave at square root, oh sorry, we leave at 1e99. So that's the change you're going to make. Let's go to solve again. Let me get rid of this. We can see. All right. So solve again. But this time we leave mu alone, but we're going to change this to 15 divided by. Now to do square root, the square root of 10, it is right here. Be careful because there's a difference between the box with the square root versus just the square root symbol. You just want to use the square root symbol. So second x squared, all right? And then you plug in 10. Nope, not 100. All right. You don't actually have to close the parentheses. You can just press enter. It's going to take you to the next page, which we left as 125. If you scroll back up, you're going to see that number change. That is 15 divided by the square root of 10. That's what that is. 15 divided by the square root of 10. That is the answer. So it's going to change once you press enter. And that's okay. All right, so scroll down to calculate, and we're going to see what was the probability of 10 people scoring an average of 125. Very little. Very, very little. Basically 0. Okay, if you basically would round that to 0. All right. So it's a lot easier for one person to score above 125. It's a lot harder for 10 people to score an average above 125. Okay. So that's the difference between last lesson and this lesson. All right. Sort of. Okay. That's sort of the difference. So let's go back to our blank page. I'm going to show you how things are going to progress. You're going to get a question, something along the lines of, the average weight of a steer, I don't really know how that's spelled. Good old phonetics. We'll just say that's what it is. Is, let's say, 1,400 pounds. No clue, by the way. I have no clue if that's true or not, but I'm just saying that's what it is. So the average weight of a steer is 1,400 with a standard deviation of, let's say, 400, let's say 1,200 pounds. No. Let's say 200 pounds. Make it easy. All right. Now, the next part is, if 73 steers are weighed, come on. What is the probability that they weigh, oh wow, phonetics are not that great, less than, let's say, 1,525 pounds. All right. So that's the kind of question you're going to get. All right. There's going to be 4 numbers we need. Okay, we need mu, and if you want to write this down, make sure you just write this down for every question. We need mu, we need sigma, we need n, and we need x bar. All right, now here's the note that you're going to want to take. These two are in the same sentence. These two are in the same sentence. All right, so the average weight of a steer is 1,400. That's the average weight of all steers. That's mu. This right here is mu, 1,400. With the standard deviation of 200. If 73 steers, that's your sample size, 73. What's the probability way less than... what is it probably... Let me write that differently, because you're going to see this word in here again. Was probably that their average weight is less than, there you go, 120, 15, 25 pounds. So when you put this in your calculator, mean equals mu equals 1,400. Sigma equals 73 divided by the square root. Nope, not 73, 200. The square root of 73. And since it's less than, we're going to change the upper bound. So the lower bound remains as -1E99. And the upper bound is the 1,525. So now I'm making this question up top of my head, so I have no clue if it's going to work out very well. It may just be 1, okay? Or really, really obscenely close to 1. All right, so let's get rid of some of this that we don't need. So I can see the buttons. All right. So solve again. The mean was 1,400. This was 200 divided by the square root, second x squared of 73. We're going to leave that as -1E99. And then this changes to 1,525. Again, it's going to be really big. It might be really close to 1. Yeah, really close. Basically 1. Okay, basically it's going to be 100%, roughly, if you round, it's going to be 100%, that the average weight is less than 1,525. So maybe I should have chosen a better average weight, but again, I'm making these questions up, so I just want you to know how to enter these things in. All right. So that's a good example. Now let's look at what else you're going to see. All right. Let's just look at the questions. It might just be easier to do that way. All right. Bunch of questions here. All right. Okay, let me see here. Trying to find a good one. Dang. Okay. Now, here's a really good question. There's a couple things happen. The production manager of a wall clock company wants to test their new wall clocks. The designer claims they have a mean life 15 years with a variance of 25. If the claim is true, the sample of 41 wall clocks was probably the mean clock life will be greater than 15.4. All right, so we have everything we just predicted, except for we're not given standard deviation. This is mu. All right, this is n, and this is x bar. It is greater than, which means we're going to change the lower bound. All right, these are all just notes you kind of want to take as you read this. But nowhere on here do you see standard deviation. If you remember my note, mean and standard deviation are in the same sentence, and technically that's still true because you are given variance. So if you want sigma or standard deviation, and that's my jumpy, it's hard to write. Standard deviation, it is equal to the square root of variance. Now sometimes it's really easy. Square root of 25 is 5, so that is your sigma. Sigma equals 5. Alright, so anytime you make a note, big note, somewhere you know you're going to see this, anytime you're given variance, go ahead and square root it. Just before you do anything else, type square root of that number in your calculator and write down your sigma value, your value for standard deviation. Because standard deviation is equal to the square root of variance. So just make sure there's a big note somewhere that says that so you don't forget. All right. So we were to put all this in the calculator. We have everything. All right. Get rid of that. So u equals 15, sigma equals 5, n equals 41, and x bar equals 15.4, and I'm going to write, we're changing the lower bound. All right, because it says greater than. So solve again. 15, and again, this has to be written as 5 divided by the square root of 41. Press enter. And we change the lower bound to 15.4, and we leave the upper bound as 1E99. So 0.3042. Again, right here, 0.3042. Because that's a 3, we just drop the numbers after it. That was a 5 or up, we add a 1 to it. So submit answer. Good. All right. So I wanted to bring that up, but I don't know if you saw me skip a few questions. I'm going to go back to those. Because you're going to be given one of 4 kinds of questions. So more notes. On this homework, you're going to be given 4 types of questions. One, find probability of the average let's say that the average. Find probability that the average is less than. All right. 2, find the probability that the average is greater than. So if you remember, this one we changed the upper bound. Okay, so change only the upper bound. And this one we change only the lower bound. All right, so those are the 2 rules there. This is the one that's where it gets a little different. We kind of have a between question. All right, we kind of have a between question. And that between question is going to look like this, okay? So let me write down what this says. The part that's the important, that says this is between. So number 3, what is the probability that's too close, that the mean, dot dot dot, whatever we're trying to sample, would differ. I know it's doing that in the background, but just ignore it. It's going to keep doing that. From, that's the key word, differ, from the population mean by less than, so differs by less than some random number. All right, so you're going to see that question, and this is basically your between question, but how you answer it and how you type it in your calculator is a little different. Not much, not really that bad. You'll just have to kind of make a note of how to type that, so we're going to bring that back up. The fourth type of question you're going to get is very similar to this. In fact, it's going to look exactly like this, but it's going to say this. Basically the whole thing. What, which I can just copy and paste, is the probability that the mean, whatever we're looking at, would differ from the population mean. So it's going to have that word differ, and there's kind of a big important word there, differs, from the population mean by more than some number. So these are the 4 questions you're going to get. We'll find the probability the average is less than, find the probability the average is greater than, and then this, what is the probability the mean of whatever would differ from the population mean by less than, or would differ from the population mean by more than. Those are going to be the trickier ones. Okay, so we kind of covered these 2. 1 and 2 we kind of covered, so let's look at 3 and 4. All right, so let's erase this right here so you can kind of see the question a little better. All right. So, suppose the best steel rods produced steel plant have a mean length of 187 and a variance of 64. So that automatically says square root 164 to get 8. So that is your sigma. Okay, that is your sigma 8. This is your at mu 187. All right. If 416 rods are sampled, so n equals 416. Blah blah, what's the probability the mean length of the sample rods would differ, so that's the word differ, from the population mean by less than 0.65. All right, so we have a differs amount, so differs by less than 0.65. Now here's the nice thing about both 3 and 4 here, both these right here. You're going to put them in the calculator the same way, but number 4 has an extra step. Okay, number 3 we just put in the calculator, number 4 we put in the calculator, and we have one more step after we get our answer. So let's put this in the calculator and just show you how we're going to put this in. All right, so, oops, that too. 416, n is 416. Let's write that down before I forget. N equals 416. All right, so we put it in very similar, so we go to solve again. All right, this time mu is 187. Sigma is 8 divided by the square root of, what, 416? Now, here's what we're going to do. Okay, anytime it says differs, at all, so differs by less, we change both lower bound and upper bound. But here's how you're going to change it. It's going to be different than what we did before. It's not like going to be, sorry, there should be a B there. It's not like there's going to be just one number, okay? We want to differ from the population mean by 0.65. So that means we have our population mean at 187. We want to be different by it, which means we can be above it by 187. I need to do this different color. Okay. So we can be above it. So 187.65, and we can be below it, 186.35. I think that's what it is. So that's what we're going to do. We're going to take the mean, and we're going to subtract the number it differs by. And we're going to take the mean, and we're going to add the number it differs by. In this case, we're going to take the mean, 187. Sorry, I'm typing, nothing's happening. 187, and we're going to subtract 0.65, the amount it differs by. Now it's going to answer that. Okay, 186.35, like we already said. Then we're going to take the mean, 187, and add the amount it differs by, 0.65. We should get 187.65. And that's what we're going to do. So you need to make note, anytime it says differs by, you're going to take the mean, and you're going to subtract the number it differs by. You're going to take the mean, and you're going to add the number it differs by. All right, that's what's going to go in the lower bound. Now, that's if it says differs by less, and we'll look at differs by more, but I'll show you what differs by more would do anyway. So we're going to go down to calculate, and we're going to press enter. So we get 0.9025. So we get 0.9025. Now, if you notice in the background, it's reconnecting. It's probably failing a bunch. Come on. I have no internet. My internet's crapping out on me again. Alright, give me a sec, get my internet back up. Okay, it's back up. So we get 0.9025. Very good. Now, here, and here's the note you want to make for if it says differs by more. So, differs by more than, has one final step, final extra step. And that is right here, 1 minus the answer. All right, 1 minus the answer, and that's not spelled correctly. There you go. So if this said differs by more than, my answer would be 1 minus 0.9025, which would be 0.0975. And that would be my answer. All right, that's the difference of differs by more and differs by less. And that's all Chapter 7 is going to ask. It's a bunch of questions, but it's only going to ask, is it less than, greater than, differs by less, or differs by more? So we're going to do a couple of these. We're going to do at least one of each. Let me clear this. All right. Suppose baby's born in large hospital with a mean weight of 325. So I'm going to write on the side, mu equals 3215. All right. The variance, I don't know what that is, but we got to square root it, so let's go ahead and square root it. Anytime you see variance, go ahead and square root. So second quit, go back home. Square root of 84681, 291. So sigma equals 291. All right. 67 babies are sampled, so n equals 67. What is the probability the mean would differ? So it differs by more than 52. So it differs by more means we are going to do my lower bound is mu 3215 minus 52, and my upper bound is 3215 plus 52. So put all this in the calculator, and don't forget, because it says differs by more, there's one more step. So second, data distribution. Let me get rid of that. That's annoying. All right. Normal CDF, that's the only one we use. So 3215, 291 divided by the square root of 67. And we're going to change that 3215 minus 52 and 3215 plus 52. 3215 plus 52. All right, calculate. So we get 0.8564. So now if I put that in, it's going to be wrong. I'll show you. It's going to be wrong. 0.8564. Yep, not correct. Try again. So what we have to do is 1 minus the answer. And that is going to be 0.1436. 0.1436. And there it is. So we got a differs by more than question down. All right, next. Mean output for certain type of amplifier is 49 watts, so mu is 498. Standard deviation, this time gives a standard deviation, that's nice, 12. 86 amplifiers are tested, so n equals 86. Probably the mean would differ by less than, so that means, again, differ by less than, was it 1.1? So the lower bound is going to be 498 minus 1.1. The upper bound is 498 plus 1.1. And because it says differs by less, there's no extra step. Once we get our calculator stuff done, we're done. To solve again, 498. Try that again. 498 12 divided by the square root of 86. Lower bound is 498 minus 1.1. The upper bound is 498 plus 1.1. All right, and we go to calc, and we get 0.604472, so 0.6047. All right, so we got a differs by less, differs by more done. Now we just need less than and greater than. Honestly, I think we'd be okay with those, but I'm going to do them anyway. We already did greater. I think we already did this one, so let's look at another one. All right, so let's do this one. Mean per capita income is 20,908. So mu 20,908 with a standard deviation of 4.7. What's probably a sample mean would be less than, so that's actually your x bar, less than 2948 if a sample of 55, so n equals 55. If it says less than, that means we're going to change the upper bound. So the upper bound is going to be that. Means the lower bound needs to go back to where it was. Solve again. Now, by the way, here's a little trick. If you press up here, it's going to take you back to this screen. If you go back to normal CDF, that lower bound and upper bound are going to go back to their standard position, so you don't have to retype that in. It's just a little trick that I noticed. 2908 407 divided by the square root of 55, and we're going to change the upper bound, so we leave the lower bound alone. 20948. 0.76695, which means it can become 7670. And we're good. All right, I think we're okay on these. I think we should be okay on these. It's really going to be the only kinds of questions you're going to get. Nothing else. All right. So that takes care of 7.2. Next, I'm going to do chapter 8.1. And it's a lot easier. It's just like 2 or 3 formulas. So go ahead and get 7.2 done and then look at 8.1.